excited to hear you talking about GPAC. I guess your big design win over the last 6 to 12 months was at a small company called, what was it? Netflix. Um, so I think your platform comes with great, or your technology comes with great credibility, and I'm eager to hear you talk about it. So let me hand it off to you.
Thanks very much, Jan. Thanks for having me, Netint. It's a pleasure to discuss the challenges when building your own live streaming cloud. Because cloud services are convenient, but once you scale, you may realize that you're paying too much and you're not as flexible as you'd like to be. So I hope to convince you that the cost of customization that you have when using GPAC is actually an investment with a very interesting ROI if you make the right choices, and that's what we're going to talk about. So for those who wouldn't know me yet, I'm Romain Boucaud, one of the principal architects of the GPAC open source software, which I've been involved with for over 15 years. I'm an open source evangelist, I'm an open standards advocate, and I'm a media streaming entrepreneur. And as you can imagine, I've spent a lot of time on GPAC over the last 15 years. So what is GPAC? GPAC is an open source multimedia framework with a very special focus on modularity and standards compliance. Modularity and standards compliance. GPAC provides tools to process, inspect, package, stream, playback, and interact with your media content. So I'll tell you more about GPAC interesting features for any team involved in the platform development within the next slides. But what is interesting is that unlike most multimedia frameworks, which are primarily designed for 2D TV-like experiences, GPAC unlocks a world of possibilities. It offers unparalleled versatility, controlled latency. It enables hybrid broadcast broadband scenarios, scalability, interactivity, scripting, virtual reality, 3D scenes, and so much more. And GPAC has been a massive successful effort to streamline the MPEG ISO-based media file format, which you may know as MP4, fragmented MP4, CMAF, and that is nowadays used in Dash and HLS. The efforts on the file formats were awarded by a technology engineering Emmy Award. I was looking for the name. We believe that GPAC played a part by providing early implementations, state vectors, and the GPAC team expert vision and leadership sometimes, thanks to hundreds of contributions that we made at MPEG. And to provide this technology, this open source technology to all businesses, I created MotionSpell. MotionSpell is the bridge between GPAC and its real-world applications. MotionSpell's expertise extends beyond consulting, support, and training. We are a driving force that enables organizations to fully harness GPAC's potential. As the exclusive commercial licensor of GPAC, MotionSpell provides a full range of professional services, ensuring that you can tap into GPAC's capabilities for your specific needs. And that's really important, and that makes a difference, as we will see in the next slides, where I will present three different industry use cases. Many companies are faced with a difficult choice when deciding how to encode and package video. The main options are to go for a commercial solution or whether to go open source and to which extent. However, in my case, many companies lack the confidence or skills to fully implement GPAC, but it's possible and it's easier than you might think. So how do you decide what is the right solution for you? And what are the reasons why it's better to implement GPAC in your video streaming operations for transcoding and packaging? So we noticed that our customers face three major challenges. So let's present them, and I have three more slides, as I said, for you with the three uh, business cases. So the first challenge is related to features. So of course, you need to make lists to know exactly what you need. I think a first sub list that you can make is about the capabilities, the codecs, the formats, containers, DRMs, captions, and also how you plan to deal with metadata. Metadata is increasingly important. I think a second sub list that might help is also what we call playing nice with the ecosystem. You will need to interact with external players, analytics probes, ingesting specific contents with some specific protocols. Adrian just mentioned the need sometimes to transcode some of the codecs. So you need to play nice with the ecosystem. And the last sublist, about the features is about extensibility. Like you need to experiment with, let's say, low latency, HDR, or we were talking about interoperability. Sometimes you need to add custom flags to support some exotic devices, for example, etc. So some solutions come with some nice graphical interface, but yet to handle all those codecs, all those parameters, all those specific use cases, you need to dig into some configuration details to make it work at the larger scale. Netflix used GPAC and they operate at the larger scale, so I think there's no question here for GPAC that it supports the features. And when it comes to features and innovation, GPAC takes root in research and standardization. So it is often one step ahead of the industry, but yet we cannot implement everything. And that's why an open source software like GPAC also needs sponsorship and contributions from the industry. Another reason why GPAC plays nice with the ecosystem and we're widely available mostly because of our efforts in standardization, people use GPAC as a reference implementation. And also the other thing is that thanks to MotionSpell, GPAC is part of many plugin systems already available in the industry. The second challenge is cost. I think that's really important. So what is cost and how do you optimize it? So usually we divide it into CapEx, which is the capital investment, the initial cost, and then OpEx, which are the operational running costs. But you also have some other metrics, for example, such as environmental efficiency. GPAC is written in C, and C is known for its speed. As an open source software, it's been scrutinized by thousands of eyes. So, there's good chance that GPAC is already as efficient as possible, or that, people, if it's not the case, people will complain about it or make proposals. So if we consider that it's efficient and we can, focus on the money aspect, it's difficult also to evaluate the cost because each use case is different. So there is a lot of features in GPAC, and each people, come with their use cases. But sometimes you may ask yourself questions such as, do I need a CDN for all my channels? Do I need premium encoders for all my contents? So I'll have a look at the Instagram use case in a few slides. But fortunately, I think for our audience today, if you consider to move to your own cloud, you already have a clear idea on what your architecture will look like. On the CapEx, there is the cost of integration. And when using some open source software, integration is important. So some costs also are probably non-trivial to evaluate. So for example, dealing with errors. When you're in operations, you have errors. And I have another industry use case for this with the Synamedia Cortex architecture that shows that errors can be handled smartly and efficiently. Also, when it comes, I think that when people think about open source, they think about free software and the cost. A couple of months ago, I was invited by OTTverse to compare the cost of the different options. So there was a seminar called Buy versus Build versus Open Source, and it was comparing in different countries with different cost structures. And we took an example, which was a broadcaster with an existing catalog of uh, 100,000 contents and 500 concurrent pools. And the cost of the packager and doing all the packaging, there is an initial capex of around $100,000 depending on your developer rates and your country. But the running cost is then almost negligible compared at least to the transcoding cost. So the cost concentrates with open source and for packaging on a moderate capex with a low OpEx. And maybe for people listening today, the interesting conclusion is that in all the use cases, open source ranked number one or was a close challenger in cost efficiency. For me, that's a confirmation that open source, when bundled like we do with GPAC and MotionSpell professional services, with professional and efficient encoding appliances like the NetInt ones, is perfectly aligned with today's challenge on efficiency. And the last challenge is flexibility. Make sure that you move fast. We experience a fast-paced environment. So I have a slide, and we will have a look at how Netflix successively went from SVOD to AVOD, from on-demand to live, from H.264 to neural codecs, from many containers to one container. And I believe that all these moves executed over short periods of time contribute to make them profitable. And again, I think that makes a difference. You need to do the same, and you can do the same. That's open source software. And for people who are not aware, up to date at least with GPAC, GPAC provides a new application called GPAC that enables users to build completely custom media pipelines. Unlike historical applications of GPAC, which typically provided a fixed media pipeline, this new GPAC application allows for the creation of tailored pipelines to suit specific requirements. And this includes transcoding, packaging, content protection, networking, and in general, any feature you need. So let's move on maybe to this first industry use case is about the first challenge that was about being feature full. So Synamedia Cortex is a just-in-time everything paradigm. With their approach, the media pipeline is divided into small components that may fail and may be relaunched when they fail. So that's completely different from the traditional 24/7 transcoder that runs in a room, that should never fail and requires a backup for seamless switching. And interestingly, the Cortex approach works incredibly well for live, at least for live, up to a certain latency. But for the latency that we usually, deal with in the industry, it works really well. It's highly effective because it can run on any instance. You can, take these chunks and execute them on cloud spout instances that are cheaper, but that may be interrupted, or any available computer on your network. So you can generate the content on demand. So when a customer wants to watch a specific content from an exotic device, you don't need to generate it, prior to consumption. It's either in the cache already generated, or it is just in time generated, and that includes the packaging, but also the transcoding and all kind of media processing that would be needed. And eventually, Cortex was bought by Synamedia. The technology was made possible thanks to their vision and talented teams, but also a strategic and continuous partnership with MotionSpell. The second example is about the second challenge that was cost. Instagram, which is part of Facebook Meta group, mentioned that they leveraged GPAC's MP4 box to alleviate video compute times by 94%. 94%. And this choice prevented a shortage within 12 months of their capacity to provide video uploads for everyone. For me, that's really a big change, and that's a really positive perspective that there are big wins that are available. And also, I think that their move is particularly interesting. So it just made more sense for them to just transmux and package most content instead of transcoding each content, because most of Instagram's contents are watched only a few times. So the cost of transcoding in their case outweighs the savings on the distribution cost. That's perfectly in line with the efficiency trend of the media tech industry. And at the same time, if you look, you can combine it with the previous slide and the Cortex, just-in-time approach, where you could have, uh, um, a low-quality encoder that may be your phone for the content that is not that popular, and you could use a high-quality, for example, NetInt encoder for content that requires a better compression. So for people, who wants to know, the GPAC packaging computational complexity is close to a bare copy. So, that's 94% savings on compute times, because the 6% remaining are mostly inputs and outputs, for example, transfers. So, but again, that, Instagram leverages this optimization because they control their system. So that's why I think it's important. That's a big point of open source. You control everything, and it can make a big difference. And the last example is about the last challenge, flexibility. So people commented on the deal that we got with Netflix, and they asked if this was about money. This was not about money. So this happened last year when we announced that MotionSpell played a pivotal role in Netflix success, integration of the GPAC open source software in its global content operations. This integration has transformed Netflix video encoding and packaging platform, resulting in an unparalleled streaming experience for millions worldwide. Netflix and MotionSpell, myself, went on stage at the Streaming Summit at NAB this year. And in case you couldn't attend or haven't seen the replay, here are some key elements. First, Netflix explained how the ISO BMFF, so the MPEG ISO-based media file format, MP4 CMAF, is ubiquitous in their workflows. Of course, they are dependent on external providers. So, ingested content may be in two main formats, as they explain, and one of them is a ProRes format, which is Apple Move, which belongs to the ISO BMFF family, and we have some good support in this in GPAC. And mainly the recommendation of Netflix for all the formats that they ingest, including the ads, is to go for MP4 or Move. And the Netflix streaming service uses CMAF. And they also explained on stage that, like GPAC, we're totally aligned and committed to open standards and innovation. So by using GPAC, they got some innovations for free because other people sponsored it, or because we implemented it before they actually needed it. But also a company like Netflix sponsored some features of GPAC, such as the support of the XHEAAC codec, VP9, AV1 support, some improvements on the ProRes file format, etc. MotionSpell collaboration with industry giants like Netflix is a testament to our commitment to innovation. As I mentioned, Netflix successfully went from SVOD to AVOD, from on-demand to live, from H.264 to newer, codecs. They initiated their container convergence, and they're going to show a lot more. And that was made possible because GPAC is easy to integrate, GPAC is highly efficient in operations, and MotionSpell provides everything you need. So a last slide for the conclusion. So GPAC offers an incredible feature set, probably already beyond what you currently need. thanks to its root in research and standardization. Most of GPAC is available in one executable called GPAC. You can, try it, deploy it, and get your service running. GPAC is cost competitive because open source is free and easy to integrate. But if you want to make the most of it, MotionSpell can help, as we did with Netflix and others. And in general, we are always happy to hear about our users. And GPAC only gets better thanks to your feedback. And last, GPAC unparalleled flexibility will help you optimize and differentiate at a fast pace. Things Netflix interactive Bandersnatch, intelligent previews, outstanding captioning and accessibility. That's all for you. Thank you.